Aloha and welcome. In this lesson, we're going to be talking about vulnerability scans. So we're talking about security assessments, essentially. Security assessments, that's the testing and evaluation of a system's security controls. And by system, we mean anything like a computer, a network, an application, a web app. So a security assessment, it determines if a system's security controls are implemented correctly and if it's operating as intended. So to do these, we usually use something called a vulnerability scanner. And that's a program that's going to scan your system for known vulnerabilities. One of the ones that I've used in the past is called Nessus. There's other ones such as OpenVAS out there, OpenVAS. And these scanners, they're going to identify and prioritize the system's vulnerabilities. It's going to provide recommendations for remediating these problems that you have. So when you look at it, you're going to get like if you're using one of these vulnerability scanners, they're going to list your vulnerability. It'll usually give you a severity like high, low, medium, something like that, and it'll give you other statistics on it. So you run these at determined times, like maybe you're going to do a vulnerability scan once a quarter or something like that. So you set up these scans using your vulnerability scanners. Um, some of the things to know about the scans, they use vulnerability databases. So you've got something called the CVE, the Common Vulnerabilities and Exposures list, and that is maintained by the MITRE Corporation. It's funded by the U.S. Department of Homeland Security. And each record that they have, and it's pretty impressive, the records are written up in a way that they're labeled CVE hyphen the year hyphen the number, the sequential number of vulnerability that they found. And these numbers are not small. You'll find numbers up there, 20,000s, 30,000s. They go up pretty high because every year they find a number of vulnerabilities out there. So keep in mind this, the nomenclature that you use for labeling these, it's going to be CVE dash the year dash the number. So you can look at that and you can automatically tell looking at a CVE record what year it was and relatively how far into the year it was. You may not be able to identify the month or something, but like if you're looking at something that's 28,000, you're not talking about the first day or two of January. So just understand that. So we also have something called the National Vulnerability Database, the NVD, and that's the government repository of standards-based vulnerability management data. So the NVD includes the database of security checklist references, security-related software flaws, misconfigurations, product names, and impact metrics. So the NVD is maintained by NIST, which is the National Institute of Standards and Technology. You're going to hear that a lot. NIST does a lot in the cybersecurity realm. So they also use the Common Vulnerability Scoring System, the CVSS, and that evaluates the threat level of each of these CVE vulnerabilities. So when you're looking at a CVE record, you're going to see usually two different risk metrics there. You're going to see one by the company, and then you're going to have one or one that lists the NIST base score, and one that'll list like the company's severity rating for it. So anyhow, when you're looking at these records, it's going to have a number of pieces of information in there. It's going to have the title that we mentioned the CV dash, let's say 2023-4000. Then it's going to have like the related vendor. It's going to have the publishing date. It's going to have when it was updated. It's going to give you a little bit of information about it. It's going to tell you about the product status. It will have some reference links as well for you to follow. So when you're looking at the detail for the CVs, you're going to be seeing information. You're going to see that severity score, the medium, high, whatever. You'll have a vector along with it. So these are some of the parts of your CV records. Um, Going on to the vulnerability scan types, you've got two different types that are going to be running. You've got non-credentialed vulnerability scans and you've got credential vulnerability scans. And the amount of information you're going to be able to tell from that is going to be different. So if you're doing a non-credentialed vulnerability, you don't have access to the systems. You're going to be doing, pretty much you're going to be working with the access that an outsider would have. So you don't have any, knowledge as to, what you only have what's publicly available through scanning and things like that. The credentialed vulnerability, though, you're going to be running with system privileges in there, and you'll be able to see a lot more than you would with a non-credentialed vulnerability. And that's because the scanner logs into a system, has direct access to the components and the configurations. So you're finding out more with a non-credential, or you're finding out more with a credentialed vulnerability scan, when you're comparing the two. And then you have two different types here. So the either the non-credentialed or the credentialed vulnerability scan, they can be intrusive or non-intrusive. So the intrusive vulnerability scan is a vulnerability scan which attempts to exploit the system's vulnerabilities found during a scan. So, for example, you could try to install malware on something while exploiting a vulnerability that you find. You can also have the non-intrusive vulnerability scan. That's basically when you're just scanning it and you're going to identify and report the vulnerability, but you're not actually going to try to exploit it. Then we have the different types of scan errors, the vulnerability scan errors. We have type 1, type 2. Those are known as false positive and false negative. False positive is when something flags when it shouldn't have. So let's say your scanner's running and it says, hey, you've got a problem with such and such, but you actually don't have a problem with that. That's a false positive. A false negative is a situation where there is a problem and you don't detect it. So false positives can be a bit of a pain. They can get you, spending time and resources trying to figure out how to make it, not trigger on that one without weakening your security. And the false negative is a more dangerous side because the false negative is you've missed that check. You've actually missed your, on your scan, you missed that, the problem that you had. So your system is still vulnerable, and that's a bigger problem than a false positive. Moving on, we've got something called SCAP, and SCAP is the Security Content Automation Protocol. And that's a collection of open standards that are used to automate the process of securing your IT systems. So that, again, it was developed by NIST, the National Institute of Standards and Technology, and it uses a standardized framework for implementing network security across the various platforms and environments that you have in your system or in your company. So the SCAP's functions, they include automating the vulnerability management, the measurement, and the policy compliance evaluation. And that's good because when you have an automated system, it's a lot better than having to go through everything manually. So when you have a comprehensive, suite like that, it just makes things a lot easier to catch, detect, and have as a regular part of your cyber hygiene. So by using SCAP, organizations can enhance the security protocols through automated processes, ensuring compliance with standards and reducing the exposure to security risks. And that's it for our section here. Again, we're talking about vulnerability scans. We started talking about the security assessments, which is evaluating your system, security controls for your system. We talked about using vulnerability scanners. We talked about some of the data you get out of a vulnerability scan. We talked about the formatting of it. We talked about the common vulnerabilities and exposures list, which is the list maintained by MITRE that has the CV list that has all those vulnerabilities and exposures. We mentioned the National Vulnerability Database, the Common Vulnerability Scoring System. We also went into detail about the two different types. You've got non-credentialed and credentialed scans. Non-credentialed gives you less information. Credentialed is going to give you more information because you're running with system, privileges or internal privileges. And then you've got intrusive versus non-intrusive. Intrusive being you're trying to exploit it, and non-intrusive is where you're just detecting and reporting it. And then we have false positives and false negatives. False positives being the least dangerous, but you can end up, if you've got a false positive, it's flagging an issue that's not actually there. So you have to dig into that and figure out how to keep that from happening again without losing your security. And then false negative is the more dangerous one because in a false negative situation, you're not flagging a problem that actually exists so that you're not catching that vulnerability. So those are known as type 1 for false positive and type 2 for false negatives. And then we talked about SCAP, which is a security content automation protocol. And that's it. So if you have any questions, feel free to reach out. Aloha.